Welcome. Thank you. I know there's tons of choices. I know like the first hour yesterday, I wanted to go to 5 talks, and there's one of me. So thank you for coming. We appreciate it. My name is Spencer Gibb. I am the lead and co-founder of the Spring Cloud Core projects.
And I'm Cora Iverclyde. I'm a platform architect for Pivotal. So our topic today is our reactive architectures with RSocket and Spring Cloud Gateway.
Yes, legalese.
Yeah, we didn't say anything.
Forward-looking things that are coming as this is in active development.
So we're going to talk about reactive architectures, go into RSocket a little bit to give you a little bit of background, and then we'll dive into Spring Cloud Gateway RSocket in particular, and demo some stuff at the end. So reactive architectures. So Reactive Streams in general is an initiative that tries to provide a standard for asynchronous stream processing with non-blocking back pressure. So what's most important here is that it's an architecture for non-blocking, right? It doesn't matter if it's synchronous or asynchronous so much as it's non-blocking. So generally, these architectures have an event loop inside of them. So we see things like Netty or JavaScript, for example. They've been using these architectures for a while, and now these architectures are incorporated into Spring as well. So that's within a process, right? So between processes, how you transfer your data between processes can be asynchronous or synchronous, right? And when we get into the idea of reactive, what's most important is that it's non-blocking and that there's back pressure. So back pressure means that there's a mechanism to communicate how the flow of data, if it's too much or if the flow is okay. So basically, the idea is a requester sends a request to another process and receives data back. It can be a stream of data. And in a general HTTP world, if the data is too much, the requester doesn't have a mechanism to tell the server that's too much data, right? You're probably just going to get some sort of error and not really know what happened. But in this world, the requester can send a signal to say that's too much, and then the responder can lessen the stream or send less data. So you might say, only give me 10 messages, and so the responder will only produce 10 messages. And in fact, one of the differences is that the responder only actually produces 10 messages, so the stream doesn't materialize beyond what the consumer is able to consume. So if we go into RSocket in particular, we're taking this reactive capabilities down to the network layer as opposed to keeping it in the JVM, right?
Who went to the RSocket talk yesterday? A few of you, okay, good.
Awesome. So, so at the network layer, we have a protocol called RSocket, which is bidirectional, multiplexed, message-based. We'll get into these things a little bit more. And it provides 4 ways for 2 processes to interact. So we have some that are familiar to us, a request and a response. A fire and forget, so a requester sends a message and isn't waiting for a response, isn't expecting anything back. A request stream, so you can send a message and get a stream of messages back. And then there's a new one, which is a request channel where a connection is established. And from that point on, either party on either side of the connection can send a request to the other and receive responses back. RSocket is also agnostic to the kind of transport that you're using. So if your network supports TCP or WebSocket or UDP generally, RSocket will work on any of those. So if we go a little bit farther in and compare it to HTTP, just to give ourselves a familiar place to start thinking about this, some of the differences are that generally in HTTP, connections tend to be a single connection, a new connection for every request, which is very inefficient. And with RSocket, we have a capability of just establishing a single connection, and it's a persistent, long-lived connection, so we can use it over and over. In terms of how many messages can be transferred on that connection, RSocket is also multiplexed, so the same connection is used in an efficient manner to transfer many messages, as opposed to pipelining them, which is a kind of halfway there. It's a more inefficient way to try to do that, or just requests that only handle a single message. we talked about back pressure, right? So if you're in the HTTP world, there's no way to communicate that back pressure, right? You might just get an internal server error back. But in the RSocket world, you have that capacity to communicate back pressure, which is interesting because in the HTTP world, because we don't have that, we tend to rely on patterns like circuit breaking, whereas if you have the capacity to communicate back pressure between two components, then you don't need a circuit breaker for those use cases. There's also this change in the concept of a client and a server, because as long as you have a connection between two processes, either one can initiate the request. So if you think about situations like mobile apps that might be posting stuff to a server but also receiving a stream. So sometimes the server side is sending the messages, is initiating the request, and sometimes the client side. And so this is very fitting for that kind of use case where that relationship is different. So you start to think in terms of requester and responder rather than client and server. RSocket also supports canceling and resuming streams, which is also really useful if you continue that analogy or that use case of mobile apps. If you're switching networks, you might drop a connection, but you were receiving messages. So in that case, the client can say, here's where I was, and just continue the stream as of this point. So you can actually achieve much more efficient communications in general, right? So I'll turn it over to Spencer.
Awesome. So with that protocol in mind, there is a need. So because you have these long-lived, persistent connections, the idea is that there is probably something, just like a TCP connection. When you make a TCP connection, you're likely going through something already, multiple times even, right? And you just don't know it. And so there's a need for a similar concept with RSocket. And so we'll talk a bit about how Gateway acts as this RSocket broker and what are some of its properties. But it's built from lots of things. And the RSocket Java implementation is built on Project Reactor, so is WebFlux. So we have a nice convergence on Reactor as the baseline for this. And then we're built on top of Spring Framework and Spring Boot. So the layer for the RSocket broker is as thin as possible, and we use patterns and pieces from these different parts of our stack. And RSocket is also available in other languages, right? It's language agnostic as long as there's an implementation. There's a specification that is agnostic of any technology whatsoever. And various companies participate in the defining of the specification, such as ourselves, Facebook, a company called Netify, Alibaba, Josh will call it a little company from China. So some great building blocks that we can start using. So before I get into it, let's talk about a few things. I'm going to say this word broker, right, which already has certain connotations in the messaging worlds. So in our case, it's something that will forward RSocket requests to routable destinations. Routing is the mechanism for creating and sharing a routing table. A routable destination or a route's simply somewhere where requests can be forwarded. And forwarding is forwarding any particular REST to a destination. And then tags are interesting. These are key value pairs that are used to look up routes in the routing table. And then there's this concept of metadata as well, kind of like headers in HTTP, okay? And then there's the concept of an origin, and that is the ID of the service where the request started. And using these things, we can start to build this Gateway RSocket broker. All right, so another, I guess, a bit of forward-looking. So we have a draft of the forwarding. So RSocket as a protocol can be extended. It's built to be extensible. And there is a an extension that is, I think there's an open pull request for it, for routing and forwarding. So what I have built and what we are using here today, because this extension is not completed and the RSocket Java project has not implemented it, what exists when we release Hoxton, hopefully soon enough, will be a technology preview. And once those things get finalized and we are integrated into not only Spring Framework and Spring Boot, we will release a service release, and this will come out of this technology preview. Okay, make sense? Awesome, perfect. So there's the concept of a broker client. And what this does is it provides auto configuration for your Spring Boot application to connect to a gateway broker. There are configuration properties to make it simple. For those of you who went to the other demo, you saw them do connect, right, and pass in a host and port. These are the kinds of things that this client library is doing for you, and you can just use configuration properties to do this. We do a special, so Spring Boot configures an RSocket requester builder, and we need to do some special things to that so that, for example, the metadata needs to be of type composite so that there can be multiple types of metadata, such as forwarding and routing, and other types of metadata like tracing, for example. And we do some other things so that we send the correct metadata to the broker. So the broker itself accepts connections from clients and other brokers, okay? So I'll get to some pictures in a minute, and hopefully it'll make a little more sense what's going on. When a client connects to a broker, there's an entry made in the routing table. I had a lot of fun learning about what a roaring bitmap is. If you want to go read a nice, fun white paper, go look at it. Basically, it's a type of compressed bitmap that is efficient and still performant. So if you like reading, geeking out, go to the roaringbitmap.org and you'll have a lot of fun. But it creates some indexes, reverse indexes, so that when I get connections from other clients that are asking for other services, the lookups are very, very, very fast. When two brokers connect to each other, they need to send some information between each other before routes can be forwarded to that broker. So this happens automatically with the gateway broker. Again, clients, all our clients are going to be written, actually one of the clients is JavaScript, but they can be written in any language as long as the metadata is set correctly. We can route from any of those client languages that we saw earlier, right? JavaScript, Go, C++, really doesn't matter. Obviously, on our side, we're focused on the Java side, and we'll provide some auto configuration and helpers to make it easy to do that. But we would have extended our demo that we're going to show out to the JavaScript side, but it was missing some things that are currently in pull request form, for example. So some of these other languages are still catching up. When a broker receives a connection to a client, it's going to turn around and advertise that client address to other brokers in the cluster via this route add method. And brokers communicate using the Spring Framework at message mapping and RSocket requester interfaces. I tried, and I wasn't looking forward to using the low-level RSocket mechanisms to communicate, and I wondered if I could get this to work, and I did. So there may be something like this perhaps in the future if any of the boot guys are listening for actuator stuff in RSocket. And again, the broker can listen on any of the official transports that are supported. So you might see a cluster of brokers that some of them listen on WebSockets and others on TCP, right? Those ones listening to WebSockets might be exposed through your router so that JavaScript clients can connect to them, for example. And security, if you saw that talk, for those of you who didn't, go watch the video later, but Rob Winch talked about the new support for Spring Security. So there's support at the connection level, which is awesome. So, hey, does this service have permission to connect to the broker? Does this broker have permission to connect to the other broker? And then for your user, services, for every request, they can be secured. Can this service make this request to this other client? So awesome support there. And we require micrometer is a non-option. It's a required dependency of the gateway broker so that we can gather metrics so you can see the health of your system at a general level, at a connection level, and then from a service to service level at the request layer. So let's kind of walk through what this looks like. So here I've got a picture, a cluster of 3 gateways, and on one side we have a JavaScript client, and one side we have a Java client, okay? When I make a connection to a Gateway RSocket, we send what's called route setup. And it really is answering the question, who am I? It sends an ID, a 128-bit number that has to be unique. It sends a service name, and then it can send tags. You can send all sorts of things like region or instance name. Another interesting one is version, right? So you can start to think about, I want to make a request to service A version 1 versus service A version 2, and the broker will automatically handle routing between versions. So here we have a picture of that. So the JavaScript client is sending a route setup. The red lines are kind of where some security can happen, right? So on connection, we check security. You'll notice that the broker does not make a connection to any service, right? Services connect outbound to the broker. So imagine how happy your security folks will be at your company when you can say, we can lock down our services such that no incoming connections are ever allowed. Think about that. But then, so the only way to get in is through the connection that the service made outbound to the gateway, right? You've just reduced your attack layer by like loads. So one of the neat benefits of this kind of architecture. So there's also not a real need for a separate service registry system, okay? So I've spent the last 5 years building abstractions over service registries, right? And now I've kind of gone and built one. So when you connect, you start to gather this routing table, and it in essence becomes your service registry, right? It has all the information about what instances are available, how to connect to them, and all that information. So we reduce the required infrastructure needed. So now when I make a request, we already have a connection. Usually what's the most expensive thing when you're making REST calls? The connection, right? How do you mitigate that usually? Connection pooling, right? You have a pool of connections so that you don't have to open one every time. Well, now we just have a persistent connection. We've eliminated that problem. When you make a request, you have to pass what's called forwarding metadata. And who do you want to call? And there's no really required set of tags that when you make a call. Personally, it makes sense. I want to call this service, right? So I would include the service name. But really, it matches on all of the tags that you include in this forwarding metadata. So if I passed region, instance name, and version, all three of those would have to match a routable destination in the routing table. So this is pretty powerful because you can use it to do these, I guess they're kind of like queries. They're these queries against the routing table. You also need to pass routing metadata. Now in the RSocket, this is a separate RSocket extension, and it is basically just a list of values. And Spring Framework uses the routing metadata to determine which message mapping in a controller to go to. Does that make sense? So forwarding, what instance do I end up on, and routing, basically what method in a controller am I trying to hit. So you need both of those sets of information. And then there's something else unique about making a request. Generally, we've talked about unicast routing. I want to talk to an instance, right? But there are others. Because we have all this information, we can start to think about making other types of requests. So a multicast request would be make this request to all of the instances that match the tags that I passed in forwarding, right? So I want to send a message to all of version 1 of the user service. We already deployed version 2. I'm going to shut version 1 down, right, and send a message to version 1 or something like that, right? You can start to think of these other ways of sending messages. And sharded, if you think of lots of databases that are sharded, you can also make requests to a subset of instances. That has not been implemented yet. So that's coming. I should have put an asterisk on that one. So here we are making a request. We pass service name equals service. I should have been like service A, because service name equals services. Very badly named. All right. My daughters are named beautifully. I don't know how to name demo services, so there you go. So but the route, the method we're going to call in our service is called echo here. So there's some notable things missing when you make a request. There's no client-side load balancer. I don't have to know, how to make a decision which instance I go to. That lives in the RSocket broker. There's no sidecar. There's no service mesh, right? Your clients, your services only have to know about the few RSocket brokers. There's also no circuit breaker. And that itself comes from the RSocket protocol with back pressure and leasing and other aspects of the protocol. There's no need for a circuit breaker. So here we have the JavaScript, the Java client making, see, there it is, service A. I must have deleted it from the other one. See? All right. I feel better about myself. This is badly formatted, though. All right. So see, this is so much easier than a keynote because I can make a mistake and point it out, and you guys laugh. It's great. So here we're trying to contact service A, but it doesn't exist. I mean, what do you do in HTTP when you call a service that doesn't exist? You don't even get a 404, right? You get like a 500. Hey, Clent. Sorry, I just noticed my friend. See, this is awesome. So what we've built into the Gateway RSocket broker is the ability for a client to make a request to a non-existent service. And the gateway says, I'm going to give you, in technical terms, I'm going to give you a placeholder RSocket that's waiting for a signal. And the way Reactive Streams work and RSocket work, there's back pressure that gets applied. So there's a signal that's coming back to the client that says, I don't have, I can't make the request. But the request is still alive, and then when something that registers that matches the request, it will continue with the request. So it doesn't matter how many people have dealt with startup ordering problems, right? It's a pain. We've just eliminated that pain, okay? I'm not sure what I was trying to point out on this slide, because that looks exactly like the last one. So I'll go here. So the requests can be filtered. So you can set up filters to say beyond Spring Security, right? So say you have some special rules about who can talk to what. You can plug those special rules in programmatically here. And again, we connect metrics at this request level. So you can start to see how does the communication between service A and service B look, right? Which is really, really interesting. So to recap, things that you don't need in this architecture. Ingress permissions, except for gateway. The gateway needs to accept connections from other brokers and from clients. Separate service discovery, circuit breakers, client-side load balancers, sidecars, ordering problems, which include like warm-ups. And in certain cases, right, in those cases where you don't need persistent messages, a separate messaging broker, right? We've taken care of that for you. Yeah, I think we're ready to move on to some demos.
We'll do a demo. So if you were at the talk by Ross and Brian and Rob, you will recognize this application, which we took from them. We put it on GitHub, so I guess it's fair. So the application is given an area on a map. So we have a browser client that displays to us a map. And given an area on that map, we make a request to get a list of airports. So we get the airports in that area. For each of those airports, so the request for that, sorry, first of all. So on the server side of this exchange, you can see the message mapping method definition. So already you can see a little bit of the RSocket implementation here. So the app that was shown in the talk yesterday it was showing RSocket, right? So you can see the at message mapping instead of the sort of a web request mapping, right? So this is a little bit of where you see how it's going to impact your code. And it's returning a flux, right? So we're going to send a request for many airports and get a stream back. The bottom is showing the client request, so you can see that it's sending the box to say this is the map area. On the server side, there's it's using Mongo and some geolocations. It gets the flux back, but it also says I only want to take, I think max count is like defaulted to 10 in the app or something like that. But you're already seeing that communication from the client to the server about limiting that stream. So a little bit of that under the covers back pressure declaratively from the beginning, right? And so the server side is only going to send 10. So once we get the airports, then for each airport or radar, those words are interchangeable in this example, for each of the radars, send me the airplanes signals, the airplanes whose signals are on that radar. So on the server side, the application called Radar Collector is on the server side. You can see another message mapping definition that returns a flux based on the type and the code of the airplane, of the airport. So if it's Dallas-Fort Worth, give me the stream there, for example. And the request on the client side, you can see that it goes through, it iterates, so from iterable. So for every airport that I got before, get me the airports on that radar, right?
The aircraft.
The aircrafts on there, right?
Yeah.
Exactly. Yes. So the application architecture logically is the flight client is the JavaScript client. Then we have a Java application that's a tracker, and the collector, which is the one that's responding to all these requests. The way it's deployed, the client is packaged in with a tracker. So there's two artifacts that actually get, two processes that get started. And so yeah, one's a WebSocket connection, one's a TCP connection. And just to give them all the credit that they're due for doing all of this work, Ross and Brian and Rob, thank you so much if you're here and if you're not on the recording for this app. So So we borrowed this app, and our idea was to put a gateway somewhere in this app. So the new requirement that we're dealing with is there's some military airports that we also need displayed on the map. But they're military airports, so they have higher security requirements, and so they need to control their own infrastructure and their own life cycle, right? When they're up, when they're down, et cetera. So we can't just add them to the same list of airports that this radar collector application is serving. It's a single instance that's giving information about 7,000 airports. If we just start up a military instance that's separate and tell the tracker application where it is and to connect to it directly, that's got some disadvantages, right? The tracker has to know where it is, and that's not really extendable, right? Tomorrow we may have a different kind of airport, or maybe we want to divide all the civilian airports into multiple instances as well. Maybe we want to separate them by continents. So if we follow this kind of architecture, it's not very forward-looking, and it's not quite as secure as really concealing the military aircraft behind something else. So we're going to put a gateway in the middle of those two. And so the flight tracker, as Spencer has been explaining, when you communicate with a gateway rather than directly to the other process, you do have to add a little bit of metadata to tell the gateway, I want to send this is for a military instance, this is for a civilian instance. But beyond that, there's not a lot of refactoring that has to happen on the client side, which is giving a lot more freedom on the backside of the gateway to continue refactoring or addressing new use cases. The JavaScript?
Yeah, I was just going to.
So we wanted to put a gateway between the flight client and the tracker as well. But the RSocket JavaScript client does not yet send the metadata that gateway needs. So next time. But
there's an open pull request, but not in time.
But that would be proving out the polyglot nature of it, right? Where you can have RSocket will already support. You already have polyglot here because you've got, the client could have been in any of the other languages supported by RSocket, but specifically for that extra metadata, it's not quite there yet.
But it is interesting to note that the flight client is using the RSocket JavaScript client and is speaking RSocket over WebSockets. Does that make sense? So the browser is making the requests directly via RSocket. And in their demo, they actually show making a request to the browser.
So, some of the advantages, right? So military collector can, in this way, by being a separate instance, control its own infrastructure and lifecycle. So we're satisfying the request, the requirements of the use case. The only endpoint that any component here needs to know is the gateway endpoint. So flight tracker doesn't need to know where the civilian radar collector is and where the military collector is, right? The gateway has the capacity to broadcast. So if there's a request that needs to go to both the civilian and the military, so for example, when the flight tracker says, in this box on the map, give me all of the airports in this area, that request has to go to both of the airports, right? So they can each say, I have some airports, there's some military airports here, and there's some civilian airports here. So that's to both of them. Or it can route to a specific one, right? So once you have that list of airports, you say, okay, for the Austin airport, I want the flights on that radar, and that is a civilian airport, so that gateway will only route that request to the civilian radar collector. And you don't need any additional service discovery, as Spencer has explained, so that's awesome. And if any of these isn't there, then, or if both of them aren't there, and the tracker's trying to get the list of airports, then at least the tracker can still make a connection to a server. And so that's one case less, right, where you need to have any kind of circuit breaker because the gateway will apply the back pressure until the collectors are up. And so this also gives us the flexibility to continue to make changes and shield the flight tracker, the client application from the impact of those. So let's look a little bit about how much work did it take to get from that application to the new setup with a gateway. So first of all, we have to add a gateway, right? So it's a new Spring Boot application with the dependencies shown here on the right-hand side of the screen, the RSocket broker and actuator. And we put a few properties in the application YAML files. Most of in the application YAML file, most of these are actually default. We added a route ID, which is required. It's a kind of a way the gateway identifies itself. It registers itself with itself to talk to others in the cluster. And So it uses ID number 1. The rest of the values, you could change them, but those are the defaults. So in reality, there's actually very little work. So you start up the Spring Boot application, and now you have a gateway. So now we have to turn our collector application, which prior to this was a server application expecting a direct connection from the client, into a client itself that will connect to the gateway. So it no longer has to be a server. So we tell it where the broker is. So when you're starting it just on your local machine, it'll be localhost, default port 7002. And when this collector starts up, it has to tell the gateway who it is, right? So it says, I am a service. My service name is Radar Collector. I also need a unique ID. Every service instance that stands up needs to have a unique ID. And for the routing purposes, it says, I want to use a tag called instance name. Your choice of what that tag name is arbitrary. There's some suggested tags. You can write your own tag. So we chose instance name is civilian in this case. When we start up a second instance of the exact same application, the only thing we change is we give that a unique ID, and we say instance name in that case is military. And that's all the information that the broker needs to know these are both radar collectors. This one's civilian, and this one's military, right?
So note you saw WebFlux on the list of dependencies. That is temporary and won't be required forever.
So then we look at the other application, the tracker application. So this was always a client, right? Before it was a client to the collector, and now it's going to be a client to the gateway. So we just changed the information about what it was connecting to before. So now we just give it localhost 7002 because that's where the gateway is. It also, every client that connects to the gateway has to tell the gateway who it is, right? Because it's not always going to be necessarily a requester. That it might need to be found by something else sending a request. And so it says, I am flight tracker, and my ID is 5. And it doesn't need to give it any routing metadata because in this particular use case, we're not expecting requests that need to be filtered in any way.
So we've assigned unique IDs. That's probably not ideal in the future. But so if you leave that off, one would be auto-generated. They're just long and ugly and hard to reason about in a demo.
And the top properties here, the WebSocket, RSocket, so this is also going to listen to requests from the JavaScript, right? So this is on the other side of the tracker application in order for the JavaScript to have that WebSocket connection to it. So, so the tracker as a gateway client, the piece of code that we add to it is to capture the requester that's generated when that connection is established. So when the process starts up, it actually connects automatically to the gateway as part of just the way that the broker client libraries work. But we need to intercept that RSocket requester in order to make method calls for it. And we only have to do this in this use case on the tracker side because on the server side, we're just receiving requests. We're not going to initiate any. So we are only doing this on the requester side of this particular architecture. And then we go into the methods that actually make those calls, right? We talked about 2 calls. The one where we say, in this area on the map, get me the list of airports. So in this case, the only code that we're changing is the stuff in red. So we're just adding the metadata that the gateway needs. So we're saying, for this view box, for that geographical area, and only give me the 10 that we said, so that was there before, go to the method called locate radars within, and add this metadata saying, I want you to forward this request to the radar collector, but multicast it to all radar collectors, right? So this is going to go to military and civilian and get the list back and retrieve a flux back. For the second method, where it says, OK, now that I have this set of 10 airports, for each airport, get me all the planes on that radar. So here we're also only adding the metadata necessary, right? So we say we do want to talk to radar collectors, but we're only instance name either civilian or military, right? And the client knows that information if Dallas-Fort Worth is civilian or military, so it includes that information and it's passed to the gateway for routing. I assume you all like to code, but You don't have to. You could also put this in your application properties file. And so we would just add this to that extra metadata we were adding. Instead of adding it to the Java code, you can just declare it in your properties file, and it will work as well.
This is one of the things that the broker client auto configuration does, is it instruments the RSocket requester to be able to add the appropriate metadata via config file.
And as a bonus, we also are deploying this to Cloud Foundry. Everything so far that I showed you, you could start it up locally. And it's the other great thing is that when you start it up locally, you don't have to mess around with port management so much anymore either, because the gateway is listening on a port, and the other stuff it doesn't matter. It doesn't have to listen on a port, or it doesn't at all. Right now things have WebFlux, but as Spencer said, that'll go away. So really, none of the other processes aren't listening at all. So now you can start a whole set of processes on your local machine without having to make sure that each one is starting on a different port that you know about because you have to connect to, or just so that there's no conflict, right? But we're still going to deploy this to show you the difference, to deploy this to Cloud Foundry. So in this case, we just want to parameterize. So instead of starting it on localhost 7002, we're going to declare through an environment variable that can be picked up what that host and port should be. So we're just parameterizing it in the application properties file, first of all here, both on the gateway side as well as the two client applications. And then in our Cloud Foundry manifest is where we set the value of what that host and port should be, right? So the host depends on whatever the host of your Cloud Foundry foundation is, and the port, there's two choices. You can either use, if you type CF domains, you'll see all of the domains available to you on your foundation. One of them should be a TCP domain. So you just put that domain in, and there's a range of ports that you're allowed to use on that TCP domain, depending on how your company set that up. So you choose one of those ports. And then Cloud Foundry will actually do the mapping to port 8080 on the container itself. So you tell your clients to connect on that TCP route to that port, and you tell your gateway to start up and listen on that. And that's it. So when you deploy it, which I'll show you that working in a second, but what you have are 4 applications running. So you have the gateway application, you have the client application, which is how you deployed the JavaScript as well, as we said. And now we have 2 separate instances of the radar collector. So the military can control itself, shut down when it wants. And you can see that only 2 are routable, right? Only the gateway is routable. You can't get to any of the radar collectors. And the route on the flight tracker is that we can use from the browser, right? And if you, instead of using that TCP domain, if you use the special domain called apps.internal in Cloud Foundry, then you actually can't even get to that gateway unless you're also on Cloud Foundry, right? So if you wanted to protect it even further, you could have, in this case, we can use apps.internal because the flight tracker is also in that same, is also deployed on Cloud Foundry, so it has access on the network. But the way that it's pictured with this TCP foundation, you could actually have a client that's off the platform connecting to the gateway. So the gateway can receive requests both from things on and off, right? And be more protected. So let me just show you that running quickly. So let's see. Okay, so this is our awesome quick internet. All right, there we go. So that's what I just showed you, right? We've got the apps running, but you can see here that the military app is actually stopped, right? And we'll go to the map and refresh that page. And you can see, so we get a list of, both requests happen one after the other. So we get the list of airports in this box, as long as, the less than 10 of them, and then get all of the airplanes that are on those radars, right? So this is thanks to those guys who did all that work. So then let me just make sure we're tracking the logs here. So we're going to look at the logs. Can I do this now? Okay, logs for that military app and logs for the gateway. So all we're going to do is come back and start that radar collector military application. I'll give it a second to start. And so the app is going to start up. It's going to go through the list of airports, filter out the ones that are military so that it's only providing information about those. And then it's going to establish a connection to the gateway. And at that point, we can refresh the page and see it all working. So right now, you can see Mongo, right? So it's going to populate that Mongo with all the airport information. And OK, so the container is healthy. We can see it loaded 2 airports. Somewhere in here it says it loaded 2 airports right here. Loaded 2 airports. That whole list only had 2. There was only 2 military airports. And if we look over here, we can see that it registered itself. So here's Route 11 should be here somewhere. Oh, I think it's.
Yeah, it's right there.
Is it? Mm-hmm. OK, I can't see. Oh, there we go. Thanks. Route 11. And I think it also says military in there somewhere. All right, so we'll go back to our page here. And we'll just refresh. And there's our military airport. Right? So now you have the multicast that it did to get the military airport as well. And we can zoom in a little bit, get rid of the other airports. And the airplane signals are random, but they should show up here as, I don't know if it's just the internet speed, but there we go. It does work. Yeah, it might be like just the speed of the internet, but it is getting signals only for that airport as well. Do we have time for?
I think we do.
Okay. Was there anything else on that? I don't think so, right? Yeah, sorry, that's. Okay.
All right, so we showed you how this was all done in a single node Gateway RSocket broker, right? But that's not the way we typically want to operate. We want multiple nodes. So here we're going to play some ping pong, okay? So, and I'll show you a demo of this. Actually, not this one, but eventually we'll see a demo of ping pong. So again, the simple scenario, Pong actually is listening on a port, ping connects directly, and they send messages. This is Cora's beautiful artwork. They're playing together. We're going to use request channel, right? So pings, so a single request is made, and then multiple payloads are sent by the requester, and multiple payloads sent by the responder, but a single request. So it's a long-lived request over a long-lived connection. Does that make sense? So what if I have other Pong friends that want to play, and they are very sad? Cora is an amazing artist. So we can solve this problem, right? Similar to what we just saw in the airport demo, right? Single gateway happens. Again, we're playing and sending requests across. In this case, we would have to specify multicast, right? So that we could send our ping to all the Pongs and get them back. But what I want to show is that we have a cluster, right? So we have high availability of this gateway cluster. And so we can have services connect to either gateway, and requests can be made to either gateway, and they will forward and choose an instance appropriately, whether it's connected to them locally or not. The demo will be simpler than this. We'll have one ping, 2 gateways, and 1 Pong connected to the opposite gateway. Does that make sense? All right. No. Yes. All right. I don't use a Mac daily. Tell it, yeah, there we go. Is it?
Yes, that's it.
Ah, yay. So what we're going to do, we'll go ahead and start Gateway 1. I make the font bigger.
I don't know if that affects the
Oh,
bottom
that
of the
was
screen.
No, that was funny. Sorry. You want the editor font, right? Yeah. You'll have to go back and fix that. All right, there we go. So we started Gateway 1 just to show you what we did, right? An ID, a route ID, service name. Okay? We're going to run Gateway 2, which is the same binary, actually the same YAML file, just with a different profile. We're going to start on a different port, but we are going to connect to the existing gateway. Right? This is a list, so it could connect to multiple of them. So right now, brokers have to have their full architecture ahead of time, right? What is the address of all the other brokers ahead of time? That will be something we work on in the future. So go ahead and start Gateway 2. So now we have right, we have this bit here, right? We have the two gateways clustered together. So now I'm going to demo our startup ordering problem, okay? Ping's going to connect first. So again, there's no Pong, so we'll see what happens here in just a second with ping. So starting up. So some interesting things here while this is starting up. We saw that we can see that, right, our other gateway connected. There's some logging information that's useful. So we've connected, and we're doing a request channel, but we see this log that back pressure has been applied. So if we go into ping, I can show you what that looks like. So one of the interesting things about something like Hystrix or Resilience4j is they could allow you to define a fallback, correct? So what might that look like in this kind of world? Well, some of the methods that are available to just via Project Reactor, there are a series of on-back pressure methods. So now you can deal with back pressure in a programmatic way. You can just drop them. Here I'm doing that and just doing some logging. There's all sorts of other things you can buffer. You can go look at the docs on those. But so we are happily connected. Our request is still sending a payload every second to Pong, and the gateway is saying, I got nothing, basically, right? 100% back pressure. So now let's go ahead. Let's see, I didn't show you ping's connection, right? Just like what Cora showed earlier. Super, super simple. So now let's look at Pong before we start it. I'll show you what it looks like. So we're connecting, we're using, what are we? We're using a different profile, Gateway 2. So we're connecting to the second gateway, which is running on 7003, not the 7002. So let's go ahead and start this guy. You see it immediately started receiving ping messages. So now ping is sending. So one of the things that's interesting, there are two extra hops here, right, between ping and Pong. In a normal HTTP situation, this would probably be bad, right? Like, I have to make these connections, or I have a pool which exhausts other resources, and there's all this latency, and again, mostly there is obviously network latency, but usually the network latency compared to the setup latency is small. So now we have persistent connections, and we only are dealing with the actual network latency between the two. And usually there should be no more than 2 hops, right? There might be just the one to the broker, and then if it's got a local connection, it would just forward right there. Otherwise, it would go to another, okay? And then we can see on the ping side that they're happily pinging and ponging each other, okay? Yay. Phone call. All right. So that's mostly what we have. I want to go over where we're going with this. Like I said in my statement before, will be a tech preview when Hoxton comes out. We're trying to follow, so Spring Framework 5.2 came out last week before? So just a little bit ago. Spring Boot 2.2 RC1 came out last week. We did a milestone the day after Spring Boot came out. Tomorrow, my team will decide if our next release is another milestone or a release candidate, which will determine whether we're like a week or 2 or 3 after the boot release. But hopefully no later than November, we'll have a release. Again, we're waiting for the RSocket extension specification and RSocket Java to come up to speed. Some of this may change a little bit. It won't look too different than what we showed, but it will be using official classes for forwarding, for example, from RSocket Java. I have some documentation to write. If anyone likes to write documentation, let me know. I can assign you some issues in GitHub. There are some clustering enhancements that we could do. We talked about them, right? You have to know ahead of time what the cluster is going to look like. I plan on adding some actuator endpoints that allow you to connect to a new, make a new connection, and also being able to dynamically get that information from a seed node, for example. We do want to integrate tracing, so things like Zipkin and Sleuth will work. There are some fault tolerance improvements. We have some load balancing algorithms that may come in the future. Imagine, for example, a scenario where you have 2 RSocket clusters in 2 separate regions, and they have a connection to each other. And you're making requests, and the local gateway cluster says, I'm going to send requests to the services that are responding the fastest, right? So normally those would be local, but if it ever got to the point where something has happened to service X locally, and the one that's far away is actually responding faster, it can start to send them across the WAN, right? You can start to think of some pretty dynamic architectures with this. So those would come in the future. And then, as I mentioned before, I have not implemented shard routing. It shouldn't be too difficult. And there's going to be lots of things as people start to use this and say, hey, this doesn't work, you're an idiot, right? Like, fix it. Yes, so this is where we're headed. I think we have some, did you want to make a shout out before
well, there's a bunch of reactive talks if you were at the keynote, some of them were listed there, but definitely check the schedule. A few have passed. And there's, so definitely check those out and check out the recordings. There's also a talk by TD Ameritrade on a security implementation with the HTTP gateway, but it's a security focus, so I think it's still really relevant, and that's tomorrow.
Yes. So here are some URLs, some contact information, our Twitter handles, and now we have some time for questions here in the front.
Two quick questions. First one is, it now sounds like you have a choice of where to handle the back pressure all along those hops. You can propagate it all the way back to the client, provide alternatives. other gateways and so on, I know that's going to make me just really screw things up a lot because I now have complete freedom to do this. How are we going to find out good patterns and things?
So let me simplify the question, like, just so that I can repeat it. What might good patterns look like for these kinds of architectures? Yeah, we're going to meet with the team tomorrow. We're going to start to talk about some of those things, right? In my mind, I see a small cluster of gateways, right, with your services all connecting to those. They might use the platform to, determine which gateway to connect to or something like that, or maybe we build something into the client. And then, how you route your services will vary depending on your requirements, right? I think a lot of, most of the time, if you think about, if you're translating something from, HTTP RESTful requests, service name will probably be fine for a lot of the cases, right? But you can start to do things like service name version 1, which is more difficult to do than before. So you start to get some options that you didn't have before. But
so you worked on the Spring Cloud Gateway stuff and associated stuff.
Absolutely.
At what point did you get super excited about the RSocket?
2 years ago at this so every year the Spring team, so tomorrow the conference ends like early afternoon, right? We keep going. And those are awesome meetings. So 2 years ago, we started talking about this, and this year we started to hit the ground running.
I have a question. Yeah. So about like WebFlux, right? So both WebFlux and RSocket build on top of the Reactor. Right? So now you're promoting the RSocket. So how the relationship between the two, right? So when we start using it, and also like when we talk about event-driven microservices, right? So then there is a service broker, right? So either RabbitMQ or Kafka right now. But how you design a system, right, enterprise application to using your RSocket and mix into the machine, right?
All right, let's take the first one. Remind me of the second one after I answer the first one. So he was talking about the differences between WebFlux and RSocket. So they're both built on top of Reactor, right? And when to use one or the other. So WebFlux is HTTP, right? That's a really good question. As I work on this, I find myself, I think I would have to talk myself out of using RSocket because of all the benefits I can see in it. Now, that being said, does every application need all the benefits that RSocket can provide? Probably not, right? So I think there's a certain class of applications that WebFlux is probably fine for, right? And it's kind of up to you. It's like any interesting question, the real answer is it depends, right? So
I guess until the client, for like in this example, for example, JavaScript couldn't have communicated. Well, no, that's
yeah, it's
couldn't
all
have
over.
communicated with the gateway anyway. So
Right.
it needed
Well,
yeah.
give us a few weeks. We'll fix
Yeah,
that part.
exactly.
But yeah, legacy. I'm sorry, I didn't mean legacy. Heritage applications, right? The ones that make you money. They may be easier to convert, like with HTTP. If you're doing migrations. Yeah. So that depends. And then the second was, I've totally forgotten.
Event-driven architecture.
Oh, event-driven architectures. Yes. So again, something we're going to talk about tomorrow. So here, if you have a class of events that don't need to be persisted, right? If you're sending over Rabbit and they're not persisted, right? I don't know how much of a difference it would make on Rabbit versus this, right? They're not persisted. Once you get to the requirement of persisting them, we're talking about, we'll probably talk about some kind of event gateway that bridges RSocket with something like Rabbit and Kafka if you need persistent messages. But yeah, this naturally fits because it is an event-based protocol. So I think it fits really well. For things that typically we do, request response right now. Now you have more options, but they don't need that persistence. This would definitely be a fit for those. Other side of the room, yes.
Could we use Eureka to find our gateway instead of getting direct
So the question was, could we use Eureka to find the gateway? Absolutely. But I've been advocating these things for 5 years, right? My goal with this would to not use Eureka. You certainly could. So I could imagine that you're deployed. So in Cloud Foundry, for example, you could create, an application that's a gateway. You scale it to 5, and then you could use the apps.internal load balancing of Cloud Foundry to automatically give you one instance of it, right? So that's kind of what I would imagine. I would imagine the next best thing, so actually similar to how clients, at least at Netflix, know where to look for Eureka, right? They basically have a big list, right? So you have this static list and, basically static IPs or elastic IPs or whatever, you have a set of well-known IPs where gateway is located and everybody just knows where those are. Something like that. But hopefully the point is to reduce. Yeah, I know. Yeah, I hear you. Yes, back here. Yeah.
How would the service-to-service communication communicate through the gateway, or there would be like a client-side library interface with the broker?
So how does, the question is, how does service-to-service communication look like? Yeah, so it is different than HTTP, right? So with HTTP, you would say, hey, service discovery, give me all the instances. Ribbon's going to choose me one, and then I'm going to make a direct connection to that guy. This, because it's persistent connections, that communication actually happens through the gateway. Gateway doesn't know about what's going on. It actually does not look at any payloads or anything like that. But yeah, Netify has done some interesting studies of how much traffic, they also have a broker and an implementation of a broker and how much traffic can go through it. So it should be a relatively small number of brokers can handle huge volumes of traffic because they're not memory constrained, right? They're just streaming data. It's all pretty efficient. Yes?
One of the first slides you mentioned that UDP can be used as a transport layer.
Uh-huh.
How hard would it be just to convert your daemon to use UDP?
So he asked that we have different transports, one of them being UDP, and how easy would it be to switch? So basically, there's a place where we do a connection and we tell it what type to use. We would just literally need to change the type to UDP. I think the UDP implementation is over Aeron. I'm not positive. Anyway, yeah, they're plug and play. The programming model. Basically, what happens is there's a bit of a driver for each of those, and then RSocket is a framed protocol, and so it will piggyback if your protocol has it, or if it doesn't, it will need to implement framing. So there are some different characteristics, but to the developer, it looks all the same. So it shouldn't be super different. And the green shirt right behind, yeah.
So I'm wondering if the missing of authentication authorization is intentional, or it's like something that whoever uses Refactoring should implement that.
So quickly, we're about out of time, but the question is about there's no implementation of authentication or the authorization here. The idea is that happens in Spring Security, right? So if you go watch the talk from yesterday, Rob Winch, lead of Spring Security, shows the implementation of Spring Security for RSocket, and it would just plug, again, this is all just a boot app, right? So bring in the right dependencies and do some configuration, and authentication and authorization would happen automatically in this. So yeah, the idea is to let Rob and the experts deal with it. So thanks for having us.